Good morning and Assalamu alaikum, my dear followers. This is video number 475. In this video, I am going to explain another example of the game theory, which is titled as the Battle of Sexes. This example is different from the prisoner dilemma or the zero-sum game, and it is also different from a single Nash equilibrium case. So in order to know the outcome, I'll explain this with the help of this example. So watch this video till the end so that you could understand the battle of the sexes. The battle of the sexes game is one of the famous games in game theory, and it is another example which explains the concept of best response and Nash equilibrium. In fact, it has more than one Nash equilibrium. Here we can explain this with the help of a story, and this story is that of player 1 and player 2, where player 1 is wife and player 2 is husband. And the story is like this, that player 1 and player 2 would like to meet each other for an evening out. They can go either to the ballet or to the boxing. Both prefers to spend time together rather than staying apart. So conditional on being together, the wife prefers to go to the ballet, whereas the husband wants to go to the boxing match. So the normal form of the game is presented in a figure on the next slide, but before that let me also show you what do we mean by ballet and what is the other event. So the wife basically would like to go to dance party or the ballet, and the husband basically prefers to go to the boxing match. So this is the story of the game. Excuse me. So let us explain the normal form of the game, and the normal form of the game is given in this payoff matrix. We measure the strategies of player 1, that is wife, row wise, and strategies of the husband, who is player 2, column wise. And there are various entries. The payoffs, the first entry in the box is the payoff for the wife, and the second entry in each box is payoff for the husband. There are 4 boxes in this payoff matrix. If we start with box 1, both players choose ballet, and that it is written as ballet, and that is in the upper left corner of the payoff matrix. Given that the husband plays ballet, the wife's best response is to play the ballet also, because in that way she would earn the highest payoff of 2. Using the notation, ballet is equal to best response of player 1. That is, ballet is the best response of player 1 when the second player chooses ballet. And we do not use the set inclusion symbol, that is, ballet is a member of the best response of the player 1, given that the second player chooses to go to the ballet, because the husband has only one best response to the wife's choosing ballet. Given that the wife plays ballet, the husband's best response is to play the ballet as well. If he deviated to boxing, then he would earn 0 rather than 1, because they would end up not coordinating. In that way, they would not meet each other for the night. So using notation, ballet is equal to best response of the player 2, given that the wife chooses to go to the ballet. Thus ballet is indeed a Nash equilibrium in this case. Symmetrically, boxing is also a Nash equilibrium, because in that case, if the husband goes to the boxing, then the wife's best strategy would be also to go to boxing. In that way, her payoff is one. But if she chooses to go to the boxing, when the husband chooses to go to the boxing, then if she chooses to ballot, then she would earn 0. So now consider the outcome. Ballot boxing, in the upper left corner of the matrix, given the husband chooses boxing, the wife earns 0 from choosing ballot, but 1 from choosing boxing. Therefore, ballot is not the best response for the wife to the husband's choosing boxing. In notation, the ballot does not belong to best response of player 1 when the husband chooses to go to boxing match. Hence, ballot boxing is not a Nash equilibrium, and it cannot be a Nash equilibrium. The husband's strategy of boxing is not a best response to the wife's playing ballot either. Thus, both players would prefer to deviate from the ballot boxing, although we only need to find one player who would want to deviate to rule out an outcome as a Nash equilibrium. And symmetrically, boxing ballot is not a Nash equilibrium either. So, in this game, there are two Nash equilibrium, ballot and boxing. They are two Nash equilibria, whereas boxing ballot or ballot boxing are not Nash equilibria. So, the ballot of the sexes is an example of a game with more than one Nash equilibrium. In fact, it has three Nash equilibria. The third one is in mixed strategies. We will explain that later on. It is hard to say which of the two have found thus far is more plausible, because they are symmetric. Therefore, it is hard to make a firm prediction of this game. So, the battle of the sexes is also an example of a game with no dominant strategies. So, in this game, there are no dominant strategies. A player prefers to play ballot if the other player plays ballot, and boxing if the other plays boxing. The following figure applies the underlying procedure used to find Nash equilibria quickly to the battle of sexes. The procedure verifies that the two outcomes in which players succeed in coordinating are Nash equilibria. So, one Nash equilibrium is this, when both of them prefers to go to ballot. The other Nash equilibrium is this, when both prefer to go to boxing, because in these two cases they are successful in coordinating. But if they choose ballot boxing or boxing ballot, then in that case they will not coordinate. So these two entries, ballot or boxing are two Nash equilibria, and boxing ballot or ballot boxing are not Nash equilibria. So this is a brief explanation of the battle of the sexes game, which explains that there are more than one Nash equilibrium, and so there are two Nash equilibria and two are not Nash equilibria. So I hope this was helpful. If you haven't yet subscribed to the channel, kindly subscribe to the channel and don't forget to click on the bell icon, so that you can get notification about my other videos that will be uploaded for you. Thanks for watching this video. Kindly subscribe to this channel and share its various videos with your friends, with your colleagues, with your students, so that they can also get advantage of watching these videos. Thank you, and see you